pamoja mtima umo. Tiende 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 pamoja mtima umo.
Welcome everyone to yet another session of Science Paper 2. This is MTN TeleSchool. My name is Mutakela Ingutu from Osaka Girls Secondary School. I'm pleased to be on this platform to revise with you, and this is the last session where we're going to answer the questions that you asked in the first two sessions, as well as go through the exam tips which is supposed to help you during your exam as you also prepare for exams. I'm specialized in chemistry. So to start with, I would want to answer the questions which we asked earlier on. The question from Charlie, explain about 2n plus. Explain about 2n plus rule. So for us to understand this question very well, the 2n squared rule, you need to also understand about the atom. So when we talk about an atom is the smallest particle of an element which takes part in a chemical reaction. So atoms are made up of, there are two things. One, shells and nucleus. In the nucleus, we find the protons and the neutrons. In the shells, that's where we find the electrons. Now, when we talk about the 2n squared rule, here we are looking at how the electrons are supposed to be arranged in an atom. So electrons are arranged in shells. So an atom, as I said, consists of nucleus and shells. So this is an atom, for instance, the nucleus is in the middle. Surrounding the nucleus, we have got shells. The first shell that is closer to the nucleus is called the K shell. You use a capital letter to represent it. Then the second shell, which is from the first shell closer to the nucleus, is the L shell. Then the one that follows is the M shell. Then the N shell, using letters from the alphabet. So each one of these shells has the maximum number of electrons it can accommodate. So the allocation of the maximum number of electrons that each shell can accommodate is done by using the formula 2n squared, where n is equal to the number, the shell number, or the number of shell. If it's K shell, that is shell number 1. If it's L shell, that is shell number 2. M shell, that is shell number 3, regarding its position from the nucleus. So as we move away from the nucleus, the number of shells, the number increases. So the first shell to start with is equal to 2n squared. So this in this case, 2. Since n is equal to the number of shells, so if we are looking at the K shell, which is so closer to the nucleus, it will be 2 multiplied by 1 squared, which is the same as 2 multiplied by 1 times 1. When you multiply this, the answer that you get is 2. So the first shell, which is closer to the nucleus, accommodates a maximum number of electrons, which is 2. And this is how the 2n square rule has come into play. So we go to the second shell. Second shell, 2n squared. Second shell is 2, or shell 2, then squared. This will give us 2 multiplied by 2 multiplied by 2. The answer which we'll get here is 2 multiplied by 2, it will give us 4. By 2, it will give us 8. So meaning that the second shell is supposed to accommodate a maximum number of electrons, which is equal to 8. Then we move on to third shell. We still use the same 2n squared rule. So this will give us 2 multiplied by 3, because now this is shell number 3 from the nucleus. Then squared. So this will give us 2 multiplied by 3 multiplied by 3. When you multiply this, you get 18 as the answer. So the third shell is supposed to accommodate a maximum number of electrons, which is equal to 18. Fourth shell. The 2n squared will also apply. So 2 multiplied by 4 squared. This will give us 2 multiplied by 4 times 4, which will give us 32 as the answer. So this is how the 2n squared rule applies when we are putting electrons in shells. The second question came from Bright Nandwe, and the question says, explain why the mass of chlorine on the periodic table is not a whole number. On the periodic table, the mass of chlorine is equal to 35.5. This is mass number of chlorine. So, mass number, relative mass number, we can define it as the mass of an element. The relative mass of an element is the mass of one atom of an element compared to 1/12 the mass of carbon-12 isotope. Now, when we talk about chlorine, chlorine has so many atoms, and it exists as an isotope. Atoms of the same element having the same atomic number but different mass number. So since there are so many atoms of chlorine that are known to exist, we need to find the average mass number for chlorine atom. So in this case, for us to do that, we use the formula relative mass number, which is represented by the letter AR, is equal to relative mass number of isotope A multiplied by percentage abundance its percentage on Earth, that's what we mean. Then you divide this by 100%. Plus, then again, this, let's say we move it here, we'll say relative atomic number of isotope B multiplied by percentage abundance over 100%, like that. So when you multiply and divide, you get the average number. So for instance, how did this 35.5 come into play? Chlorine, the question, example, chlorine has two main isotopes, chlorine 35 and chlorine 37, with abundances of 35% and 25% respectively. Calculate the relative atomic mass of chlorine. So we use the same formula. So in this case, we'll say relative atomic mass of chlorine is equal to relative atomic mass of chlorine 35 multiplied by percentage abundance plus relative atomic mass of chlorine 37 multiplied by percentage abundance. This you divide the first one by 100%. You also divide the second one by 100%. So when you divide there, we substitute, you find that the first one it will be 35 multiplied by the percentage abundance, which is the 75%, divided by 100% plus 37, which is the relative atomic mass of isotope B of chlorine. Then we multiply it by the percentage abundance, which is 25%, divided by 100%. When you do that, here, when you multiply and divide by, when you multiply, you get 2,625 over 100 plus 925 over 100. Then this will give us 26.25 plus 9.25. When you add the numbers, you get 35.5. So in other words, when we say the relative atomic mass of chlorine is 35.5, this is the average of the isotopes of chlorine. So I'm sure I have answered your question right. So get back to our exam tips. When you go into an exam room, most of the things have been said by other teachers. So I will not go on emphasizing on what has already been said. Preparation for exam is very, very important, because if you don't prepare for the exam, you are preparing to fail. So the first thing that happens is make sure that you arrive in school on time. That is one of the cardinal things, because if you get into the school 30 minutes after the exam has already started, you will not be allowed to enter the exam room. Those are the rules which ECZ has put across for you as students, and you have to follow them. So the best thing that you can do as a student is get to school early. Let's say 30 minutes before the exam starts, you're already in school. The exam is supposed to start at, let's say, 8 hours. You should be in school at least by 7:30. Make yourself comfortable. Sit as you wait for the invigilator to bring the papers. Once the paper is ready, is brought in the exam room. Mind you, you should put on your school uniform, because without the school uniform, you cannot be allowed to write the exam. Apart from that, you should have your identity card. Without an identity card, no invigilator will allow you to enter the exam room. So as you prepare for exams, early in the morning before getting to school, make sure that you're putting on a full uniform, get your identity card ready, get everything that you need for that paper, and then get into the exam room. When the invigilator comes, the papers will be distributed to everyone in the class. The first thing that you're supposed to do is do not touch anything unless you are told to do so. Then from there, read the instructions. After reading the instructions, because if you don't read the instructions, you will not understand or know what you're supposed to do when answering the paper. So read the instructions carefully and understand them. If you don't understand the instructions, please, you have the right to actually ask the invigilator to say, what does this instruction mean? So that the invigilator can easily explain to you. Then after that, when the time to start starts, don't go straight answering the questions. The first thing that you're supposed to do is write your name and the exam number. That's the first thing that you're supposed to do. Without your name, because some of the candidates fail to write, they answer the questions quite all right, but they fail to write the name and the exam number. Now, how is ECZ or the people who are going to mark your paper going to identify you without the exam number as well as the name? So the most important thing is, before you do anything, before you answer the questions, write the name and the exam number. Then from there, chemistry, when we talk about science paper 2, it has got 2 sections or 2 papers. We have science, the chemistry aspect of science is put in 2 papers. There's paper 2 and paper 3. Paper 3 is a practical paper where the first question is physics and the second question is chemistry. Section paper 2 is the theory paper, which consists of 3 sections. Section A, multiple choice. Section B, where you have to answer questions according to the way the question has been phrased. Section C, there are 3 questions and you have an opportunity to choose 2 questions from there. So to start with, we'll look at how you're supposed to tackle the questions in paper 2. So things that you're supposed to remember when you are answering questions from actually not only paper 2 but both papers. When you're writing the symbols of elements, elements are represented by symbols. When writing the symbols of element, make sure that you write the symbols correctly. For instance, when you talk about hydrogen, this is the name of the element hydrogen, and this hydrogen is represented by the letter H, not small letter h. The moment you put a small letter, it becomes very wrong. So the symbol for the element has to be written correctly. For elements that are represented by 2 letters, for instance, let's talk about calcium. Calcium is represented by 2 letters. We can't use C because C is the symbol for carbon. So the symbol for calcium is Ca. Make sure that the second letter is a small letter. The first letter, capital letter, second letter, a small letter. Apart from calcium, we also have aluminium. Aluminium is represented by the symbol L, A, L. A should be a capital letter. L should be a small letter. Not A, L. This becomes very wrong in chemistry. So note that as you prepare for your exam, you write the symbols correctly. Representation of elements or the nuclides. Every science paper has a periodic table at the end of it, and in the periodic table there's the symbol for the element which is accompanied by numbers. So for instance, the symbol for the element is represented by the letter X, and we have Z and A. Bear in mind that A represents the mass number. And then mass number is the sum of protons plus neutrons. So this number, you can only get it when you add the number of protons that are contained in that atom, as well as the number of neutrons. Z in this case represents the atomic number. Atomic number is the number of protons in an atom. And because the number of protons in an atom is always equal to the number of electrons, atomic number also is equal to the number of electrons. Bear in mind. Then X represents the symbol for the element. So we can have an example, sodium 1123. In this case, you should not confuse yourself. Know that Na represents the atom of sodium, or sodium atom. Then 11 represents the atomic number. Atomic number, which also is the number of protons. So you can also say number of protons. Then 23 is equal to the mass number. Mass number. Mass number, as I said, the sum of protons and neutrons in an atom. When you're writing the symbol for ions, we look at ions. An ion is an atom that has lost or gained electrons. An ion has a charge. If it loses electrons, it becomes positively charged. If it gains electrons, it becomes negatively charged. So when writing the symbol for the ion, for instance, the symbol for this ion X is 2, it has, let's say, 12, atomic number 12. So electronic configuration in this case is 2,8, 2. So which means that this atom X is going to lose the 2 electrons and it will become an ion. Now when writing the symbol for the ion, you're not supposed to write X plus 2. This is very wrong. But how are you supposed to write it? You're supposed to say X2 plus. So the number of electrons it has lost comes first, and then the charge follows. If it is an anion, let's say element N, let's use oxygen. Oxygen with an atomic number of 8. Electronic configuration is 2,8, not 8, but 6. So this oxygen, because it wants to be stable just like any other element, it will gain 2 electrons. When it gains 2 electrons, it becomes an ion with a negative charge. So how are we going to write the symbol for this atom? The symbol will be oxygen 2 minus, not oxygen minus 2. This becomes wrong, but that is very correct. If it's chlorine, atomic number 17, electronic configuration 2,8,7, which means that in the outermost shell of chlorine, it only needs 1 electron for it to be stable. So therefore, it will gain 1 electron, and when it gains an electron, it becomes an ion with a negative charge. So the symbol for chlorine in this case will be chlorine plus an electron. This is going to give us chlorine minus. You are not supposed to write chlorine minus 1 or chlorine 1 minus. This is very wrong. Just that minus is enough. If it's sodium with an atomic number of 11, electronic configuration 2,8,1, it loses an electron, and when it loses an electron, it becomes an ion, and it have this charge. So this is very correct, but you're not supposed to write sodium plus 1. This is very wrong. Or sodium 1 plus. This is wrong, and that is also wrong. You're just supposed to write the charge alone. Then I want us also to look at rules guiding calculations involving more concept. More concept is a topic which most of students fail to understand. But once you understand the rules that guides the calculations, you find that it will be very easy for you to tackle questions involving more concept. The first rule is that make sure that the equation is well balanced. If you're given an equation in the paper, exam paper, before you start solving, ensure that the equation is balanced. Once the equation is balanced, then you can go to the next question. If the equation is not balanced, whatever you do will not make any sense. But the first thing that you have to ensure is the equation should be well balanced with the state symbols clearly shown. When you are done with that, the next step is take more ratio of all the reactant and products in the chemical reactions. What do I mean when I say take more ratio? For instance, sodium hydroxide react with hydrogen chloride or hydrochloric acid. This will give us sodium chloride plus water. So you have this equation in the exam paper. So the first step that you have to do is check if the equation is balanced. Okay, my equation is balanced. Then you move on to the next step. You take more ratio. What do I mean when I say mole ratio? You look at the number of moles that reacted in the equation. So in this case, we'll say 1 mole of sodium reacted with 1 mole of hydrochloric acid to produce 1 mole of sodium chloride and 1 mole of water. These are the mole ratios we talk about. So take mole ratios. It's these mole ratios that from here that you'll be able to answer the questions that follows. Then from there, pick out the substance asked in the question and start solving. If the question is asking you to look to find the mass of, say, water, and then you've been given the mass of sodium hydroxide, why should you concentrate on hydrochloric acid and sodium chloride? You just have to pick what you've been asked from the equation and start solving. So in this case, we'll say sodium hydroxide to water. That's our main, that will be our concentration, because the question comes from there. We are looking for the mass for water, and also we've been given the mass for sodium hydroxide. So pick out the substance says asked in the question and start solving. Now, as you are solving, note that the relative molecular mass of substances is equal to the sum of all atomic masses of the atoms. So the relative atomic mass, for instance, of sodium hydroxide or water will be equal to the relative atomic masses of the atoms that are present in the compound. For instance, sodium will say sodium, we have 1 atom of sodium multiplied by 23, which is the mass number. Oxygen, we have 1 atom of oxygen multiplied by 16, which is the mass number. Hydrogen, we have 1 atom of hydrogen multiplied by the mass number. This will give us 23, this will give us 16, and this will give us 1. When you add this, it will give you 40. So 40 is the relative molecular mass, or relative formula mass for sodium hydroxide. And for water, relative molecular mass will be H will give us 2 multiplied by 1. Then oxygen, 1 multiplied by 16. This is 2. This will give us 18. When you add, not 18 but 16. When you add this, it will give you 18. So the relative molecular mass in this case is 18. Then also note that 1 mole of any gas at room temperature and pressure, which is RTP, occupies a volume equal to 24 decimeter cubed, or 24,000 centimeter cubed. In this case, you should also bear in mind that 1 decimeter cubed is equal to 1,000 centimeters cubed. So 1 mole of any gas at room temperature and pressure occupies 24 room temperature and pressure 1 mole of a gas occupies 24 decimeter cubed, or 24,000 centimeters cubed. Now, this is at room temperature and pressure. How about at standard temperature and pressure? 1 mole of a gas occupies 22.4 decimeter cubed, or 22,400 centimeters cubed. Note that. Then note that 1 mole of any substance contains 6.02 times 10 to the power 23 particles. So note that also 1 mole of any substance contains 6.02 times 10 to the power 23 particles. This is what we call the Avogadro's constant. All masses equivalents are assigned arbitrarily mass units in grams. So when you are calculating mass, the units that you assign for mass are grams, using a small letter, not a capital letter G. This is very wrong, but small letter G is very correct. Unless a question demands you to calculate to find the mass of a substance in kg, if it demands you to find the mass in kilograms, then you put the units as kg, which is kilograms. So when you are writing kilograms, capital letter K and small letter G, not kg like that. This is very wrong. Now, units must be written when you are solving, when you are carrying out some calculations. Make sure that units must be written on a correct answer. For instance, if the question demands you to find the mass, at the end of the calculation, if your answer is 8, your answer should be 8 grams. For instance, let's take for instance, find or calculate the number of moles contained in, let's say, 8 grams of sodium hydroxide. So, for us to find the number of moles, we use the formula Ne is equal to mass over molar mass. And looking at our question, we've already been given the mass, which is 80 grams. Then our molar mass comes from sodium hydroxide. And the symbol for sodium hydroxide is NOH, which will give us, when you get the molar masses of the atoms that are present in sodium hydroxide and add them, you will get 40. So 40 gram per mole. So gram and gram will cancel. Then 4 here, 1. 40 here, 1. 40 there, 2. So the number of moles will be 2. You are not supposed to just write 2 on its own like that. But you are supposed to write the correct answer with the correct units, which is the moles like that. Then this answer becomes correct. The moment you forget to write the unit, the answer becomes very wrong. So each time you are calculating, remember to put correct units on the correct answer. Then 4 marks will be awarded to you. We take a short break. We'll be back soon. Thank you.
I told the bus driver that I work hard for my money, so it better gets to Chipata.
Yeah, that's right. That's what I told him.
Yeah.
Weather, drama is no. Only Zambili.
Tituma. And he kept trying to tell us something, but I was like, Ukagamba, Tilo.
Cause cash money yeve across Zambia.
Tituma. Ati? At Basi and Kuchpat. He ended up South Africa. Hello, what?
Run, K-Stop, run! Don't catch the bus.
Sending money doesn't have to be this dramatic. Open an MTN mobile money account today and send money to friends and loved ones across Zambia instantly. Dial *303# to send money with MTN, Zambia's #1 network. With MTN mobile money, Tituma.
MTN, everywhere you go. Rise up this morning, smiled at the rising sun. Three little birds pitched by my doorstep, singing sweet songs, our melodies pure and true, saying, this is my message to you. Singing, don't worry about a thing, 'cause every little thing is gonna be alright. Singing, don't worry about a thing, 'cause every little thing is gonna be alright. Cause every little thing is gonna be alright.
How you use your data is up to you. With the widest network coverage, it's amazing what you can do on MTN.
This is my message to you.
Welcome back, viewers. Thank you so much for tuning in to MTN TeleSchool. Remember to tag in your friends and relatives so that they can also join in the watching. Send us your comment and your questions, and also tell us where you're working from. Andrew Mutale, I am able to see you there. Thank you so much for being with us. Now we move on to exam tips. There are certain times, or there are certain mistakes that students make when answering questions that involve graphing. So let's look at what we are supposed to put in place when we are answering a question that needs to, you need to plot on a graph. So the things that you're supposed to put in mind are these. Make sure that the A4 paper that you're given for the graph, 3/4 of the space is covered. Of the graph paper is covered when you're answering a question on a graph paper. Then from there, make sure that the axes are labeled correctly with correct units. Axis labeled correctly with correct units. So for instance, what do I mean when I say axis should be labeled correctly with correct units? If you are plotting a graph of, let's say, concentration against the time. So in this case, your graph will look like this. Make sure that you indicate with the arrows like that, the x-axis and also the y-axis. So time, indicate that this axis is for time, you label it. And as we know, time is measured in seconds, so you put S there. That is the correct unit for time. Then you come to concentration. Concentration, like that. Then we know concentration is measured in mole per decimeter cubed. Indicate the units as well. So mole per decimeter cubed, like that. Then you find that you get a mark just for that. Then after that, all the points that you are given, if you're given a table, must be correctly be plotted. You're supposed to plot all the points. If you are carrying out a test in the lab, make sure that for every test that you carry out, the points have to be plotted on the graph. Then from there, come up with a smooth curve. Join the points and the and form a curve. The points, the line that joins the curve should be, that joins the points should be smooth. For instance, we have a point here, maybe we'll have another point here, another point there, another point there, like that. So as you join the curve, it has to come down like that nicely. So it has to be smooth. Or maybe the graph is going like this. Points have to be visible like that. So join the points like that and form a smooth curve nicely. Like that. Then your graph should also have a title. And in this case, our example, we are looking the graph that we have as an example is a graph of concentration against time. So you need to write on top there, the title of the graph is concentration against time. Once you do that, you find that from the 5 marks or 6 marks which will be allocated to the graph, you'll be able to score even 3, 4, or 5 marks if you follow the instructions carefully. So the first thing that you need to do when you're plotting, 1, make sure that your graph has a title. Before we come to the title, 3/4 of the graph is covered. Make sure that that is done. The axes are labeled correctly with correct units, both X and Y axis. Then from there, all points must be correctly plotted. Then when joining the points, you're supposed to have a smooth curve. Then make sure that you have the title of the graph. Then from there, I want us to go into another tip that will help us in as we prepare for exams, both the theory paper as well as the practical paper. And in this tip, we'll look at qualitative analysis, which is when you are testing for the presence of the cation or the anion. So for instance, the test that you're carrying out is test for cation in a solution. When testing for a cation using either sodium hydroxide or aqueous ammonia, 2 observations will help identify the cation present. So as you carry out the test, there are 2 observations that will help you to identify the cation that is present in the solution. 1, observation on qualitative analysis. One, the color of the precipitate formed, of the PPT formed on adding few drops of the reagent. So the color of the precipitate formed is very cardinal. Well, after adding few drops of the reagent given. The reagent can be sodium hydroxide or aqueous ammonia. So for instance, when you are testing for the presence of aluminium cation, you find that the precipitate which is formed there is white. For zinc, the precipitate also is white. If you are testing for the presence of copper cation, the precipitate is blue. So observing the color of the precipitate formed by adding few drops of chemical reagent is one observation which will make you be able to determine or identify the cation that is present. The next observation is the solubility of the precipitate in excess chemical reagent. The solubility of the precipitate, which is PPT, in excess chemical reagent. When you add excess chemical reagent, what will happen? That is also another thing that you have to observe. After adding few drops, you observe a precipitate, the color of the precipitate forming. Now, when you add excess, what happens? For instance, when you are testing for the presence of aluminium cation, after adding few drops of the reagent, you find that a white precipitate is formed. And that white precipitate is insoluble in excess. When you add excess reagent, the precipitate is insoluble. It will not dissolve. If we are identifying for the presence of zinc cation, a white precipitate will also be formed. But when you add excess reagent, the color would disappear. Why? Because the precipitate becomes soluble. It will dissolve. One thing that you have to know is that cations react with hydroxide ions present in aqueous sodium hydroxide and ammonia to form an insoluble hydroxide. These hydroxides appears as the precipitate. So for instance, you can have ion 2 plus, this is the cation. So when it reacts with the hydroxide that is present in sodium hydroxide, a precipitate will be formed, which will this precipitate is ion to ion hydroxide, which is green in color. That is the precipitate. Some of the precipitate, bear in mind that dissolve in excess aqueous sodium or aqueous ammonia to form soluble complex salt. These appear as colorless solution, or in the case of copper 2 ion, in excess aqueous ammonia, a dark blue solution is formed. Cations are identified by their characteristic color. Copper 2, green color, copper blue color, iron 2, green color, iron 3, reddy brown color. Tests for gases. When you're carrying out a test that gives off a gas as a product, it's important that you should also be able to identify the gas that is produced. Now, when testing for the gas, things that will help you to identify the gas. When recording observation of gases, it's important to record 1, the presence of effervescence, if any. And a very good example of a gas which shows effervescence is carbon dioxide. So when recording observations for gases, it is important to record one, presence of effervescence, if any. 2, the color and the smell of the gas. Ammonia, for instance, is a gas that has a smell. So you can identify it by its smell. You can record that observation that the gas which was produced has a smell. Color, when we talk about color, for instance, when you bring in an indicator on a gas such as ammonia, when you put a damp red litmus paper on a test tube, on the mouth of a test tube which contains ammonia, the litmus paper will change its color to blue. So the color change will tell you the presence of ammonia. Then apart from that, chlorine also is another gas which shows color change. When you bring in a blue litmus paper, it changes to red. Why? Because chlorine has the bleaching effect. Then apart from that, the chemical test for the gas. Chemical test for the gas and test result. E.g., when you talk about chemical tests, certain gases are identified by their chemical test. For instance, carbon dioxide. The chemical test for carbon dioxide is that it turns lime water milky. That is the chemical test for it. So how do you carry out the test? By bubbling the gas through lime water or calcium hydroxide. When you bubble it, the lime water will form. Then apart from that, oxygen relightens a glowing split. So by putting a glowing split or a burning split on the mouth of a test tube which contains oxygen, the flame will burn brighter. Hydrogen. The identity test for hydrogen is that it turns, it puts off a flame from a burning split with a pop sound. Then we have ammonia. Ammonia turns damp red litmus paper blue. Then chlorine gas. Chlorine turns blue litmus paper red. Then sulfur dioxide. Sulfur dioxide also turns blue litmus paper red. Then apart from that, sulfur dioxide also changes the color of potassium dichromate from orange to green. The presence of sulfur dioxide changes the color of potassium dichromate, which is orange, from orange to green. Then from there, you should also be able to give the name of the gas. Give the name of the gas. Name of gas. Because of the chemical test that you carry out to identify the gas and the results that come out with the test, you should be able to name that gas. For instance, carbon dioxide, when you bubble it through water, lime water, it turns lime water milky. When you put a glowing split on oxygen, it relightens the glowing split. Hydrogen, when you put a burning split on the mouth of a test tube that contains hydrogen gas, the burning split goes off with a pop sound. That brings us to the end of this session, which is exam tips. Thank you so much for tuning in to MTN TeleSchool. My name's once again Mutakela Ingutu from Lusaka Girls Secondary School. It has been a pleasure revising with you. I'm happy that Emelda Mary Jere, you are watching wherever you are, and Richard Hadik, Matilda Mumba, I'm happy that wherever you are able to watch the show. Thank you so much for tuning in. Inform your friends and your relative to download the MTN TV Plus app on their phone so that they are able to watch the recorded videos of the lessons that have been going on. You can also inform your friends and your relatives to like the MTN Zambia Facebook page so that they can also join in the watch. Thank you so much and have a blessed evening. Thank you.
Tiende pamoja ni mtima umo. 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 Tiende pamoja